Okay, so here's another way to look at that problem. Problem number 5 in our review packet. And this way, let's think about this problem again. So avoid using red. All right, so I know I have 49 grams of this, and I know I have 80.0 grams of the NaOH. And remember from the previous one I did that it was balanced like this. And I want to know which one gets used up first. So another way I could think about this is if I convert my grams of H2O to grams of NaOH and my grams of NaOH to the grams of H2SO4, I can figure out, okay, how much of the other one it uses up. So for example, let's take an example. So for example, I know I have the grams of H2SO4 and I can convert that to the moles of H2SO4. And once I'm at the moles, I can convert to figure out how many moles of NaOH that would mix with, right, through the molar ratio, 1 to 2 in this case. And then I convert to grams of NaOH to determine how many grams of NaOH that would need to mix with. Okay, so I have 49 grams of H2SO4. And I got this all from the box. The steps, or that's my thinking. If you want to set up the box, you would get the same thing. But we want to cancel out the grams of H2SO4 to the moles of H2SO4. I know in 1 mole of H2SO4 there are 98.00 grams about. And that'll get rid of my grams, and now I'm at moles of H2SO4. Okay, but I want to keep going because I want to figure out how many grams I'm reacting with. So I can figure out, all right, in 1 mole of H2SO4, I'm trying to figure out how many moles of NaOH there are. Well, in 1 mole here, I need to mix with 2 moles of NaOH for this reaction to happen. So that goes there. My moles cancel out. I'm at moles of NaOH, right where I want to be. And now I've got one final step to the grams of NaOH. So in 1 mole of NaOH, how many grams are there? Well, I look on the periodic table, right, for the molar mass, because I want to figure out how many grams of NaOH. And that's going to give me 40.00 grams if I were to look at the periodic table and add all these up. All right, so I take 49 divided by 98 times 2 times 40. Seems to give me 40 grams of NaOH. So what did I just figure out? Well, if I have 49 grams of H2SO4, it can mix with 40 grams of NaOH. Well, do I have 40 grams of NaOH available? I do. So this is possible because I only need possible because I only need to mix it with 40 grams. I have 80 grams. So how much is going to be left over? Well, let's see. I have 80 grams of NaOH, right, from the start. I know it'll mix with 40 grams of NaOH. I need 40 grams of that NaOH to mix with the 49 grams here. So how much is left over? 80 minus 40. Oh, I still have 40 grams of NaOH left over. Now, it's not always going to be the same as you used up. That was just a coincidence in this problem. So be careful with that. But otherwise, this seems to be an appropriate way to set up the problem. Now, I just want to show you one other thing is, what if I did the 80, was it 80? 80, I need to go back, it's up there. All right, the 80.0 grams of NaOH, what if I started with that and try to convert to the H2SO4? What would happen here? So in other words, I'm trying to go this way. I have 80 grams, I want to get to the moles. All right, so I have grams of NaOH. I can convert that to the moles of NaOH through the periodic table. From there, I can use my molar ratio to get 2, just like in the previous one, to get to the moles of H2SO4, and then I can figure out, okay, how many grams are in that H2SO4. All right, so in other words, if I have 80 grams of NaOH, how many grams of H2SO4 do I need to mix with it? So let's think about that. 80.0 grams of NaOH. I want to cancel out the grams of NaOH. I want to get to the moles of NaOH. I know that's a molar mass. If I look in the periodic table and add up all those elements, there are 40 grams in 1 mole of NaOH. So let's cancel that out. I'm now here at the moles of NaOH. I don't want to stop there. I want to keep going. I need to cancel those moles of NaOH. I'm going to convert from the moles of NaOH to the moles of H2SO4. Well, in 2 moles of NaOH, I mix with 1 mole of H2SO4. The moles of NaOH done. I'm at moles of H2SO4. That's where I want to be. And one final step to cancel out the moles of H2SO4. I need to figure out how many grams of H2SO4 there are. Okay. Well, I know in 1 mole, if I look on the periodic table, I know there are 2 H's, 1 S, 4 O's, and that adds up to 98 grams of H2SO4. And if I do that calculation, 80 times 1 divided by 40 times 1 divided by 2 times 98, I get 98 grams of H2SO4. And what that tells me is 80.0 grams of NaOH, what I started with, can mix with 98 grams of H2SO4, okay? But how much H2SO4 do I have? I only have 49 grams of H2SO4. So, in other words, not all of the NaOH will mix, okay? And so now I've got to go back and take my H2SO4 and convert to NaOH to see how much it'll use up, just like I did in this problem. So if the first one doesn't work out, I've got to try it the other way around, and that's one way I could see whether it will work or not. So here's a different approach to the excess reagent problem, where you need to figure out how much is left over of one. All right, so whichever way you like better, go ahead and use. They're both valid, and I hope this was helpful. Again, good luck in your preparations, and may the sun shine brightly upon you all. King, out.